Teledyne PDS and real-time navigation setup basics. PDS can be used for basic navigation as well as for more sophisticated survey and construction applications. Navigation forms the foundation of all these workflows. In this video, we will familiarize the user with several key features of PDS navigation. Let's first take a look at the basic configuration settings. The coordinate system is configured in the project configuration. For each project, it is essential to select the correct coordinate system. PDS provides a database containing an extensive list of coordinate systems, organized by country. Select the coordinate system appropriate for your project. The configuration page is used to manage vessels within the project. You can add and configure multiple vessels. In this example, we are working with one vessel only. On the geometry page, you can define the vessel shape used for real-time visualization. This can be a standard predefined shape or a custom shape. In addition, offsets for onboard devices, such as GNSS antennas, are defined here. Click on the Overview button to visualize the offsets in the 3D shape. In the Equipment page, we manage our devices. Devices are organized into device groups. Each group supports multiple brands and data formats. Notice the document icon next to a device driver. Click this icon to open the device-specific configuration information. For navigation, it is important to correctly set the GNSS antenna device offset and the height mode. Double-click the added position device to open the device properties and set the offset as defined earlier on the geometry page. Next, double-click the reference point computation to open the computation properties. Set the height mode to RTZ height if the GNSS receiver outputs accurate heights, for example, when using RTK. Alternatively, select tide when a tide gauge is used as the height input. Do the same for all added position devices. For the heading device, the heading correction must be configured in the device properties. For the attitude device, the mounting correction angles for roll and pitch are configured in the attitude device properties. Next, we move to the computation page. This page allows you to add advanced computations to the project, such as an additional offset computation. Next, we move to the data sources page. When multiple data sources are available, such as multiple position devices, this page allows you to define which source is used as the primary one. More advanced options also allow switching between sources based on defined conditions. Next, we move to the guidance page, which allows you to manage guidance files. For navigation, this typically includes runlines, waypoints, and routes. The tools, logging, and simulation pages are not required for a standard navigation project and are therefore skipped in this tutorial. Because device drivers may have technical names, the aliases page allows you to assign a user-defined name that is shown in the configuration. And last but not least, the alarms page is used to define alarms. The events page is not relevant for navigation and can be ignored. We have briefly walked through the configuration pages. Each page will be explained in more detail in separate instruction movies. We now exit the configuration and start real-time acquisition. Real-time acquisition requires a dedicated screen layout for operational use. This is just an example of a defined screen layout. You, as a user, is in total control of the views to be displayed, the number, the size, and the location. From the Add Displays option, all views permitted by the license are listed and organized into groups. Select the view you want to add. Organize the views in the layout. PDS provides different view modes. Use docking mode to quickly lock a view to a fixed position. The views added to the layout are managed from the Displays option, where they can be removed or disabled. Let's now take a closer look at the most commonly used views in navigation. In almost every project, a plan view is used. The plan view navigation displays the vessel in a grid from a top-down perspective. Enable the Follow Vessel mode to keep the vessel centered in the view at all times. Right-click in the view to open the context menu, which provides quick access to options such as adding waypoints or drawing a route or polygon. Adding, deleting, or modifying the data displayed in the view is managed through View Layers. Open the View and Layer control. As you can see, each data information type has its own layer, allowing you to configure the relevant settings. The vessel layer visualizes the vessel in the view, using the shape that is defined on the geometry page of the vessel configuration. Any guidance files are shown through the guidance-related layers. The view distinguishes between active and non-active layers. Active layers, like the active route layer, indicate the route currently used for navigation. Non-active layers, such as the route layer, are displayed for reference only. Active guidance files are selected from the Guidance menu option. In this example, the route file named Navigation is selected as the active route and displayed in the view. Background charts are commonly used in a plan view for reference. PDS supports web maps, allowing charts to be displayed in real time when an internet connection is available or from previously downloaded data. However, many other formats and data layers are supported as well. These can be added by clicking the plus sign in the View and Layer Control dialog. As listed, PDS also supports S57, S63, DXF, and GeoTIFF format charts. In addition to the other available data layers, the position marker layer can also be useful for navigation. By adding this layer to the view, any position source or computation can be indicated using a marker. Guidance files can be created or managed in different ways, depending on the workflow. From the Guidance menu, which we have seen earlier, click New to create a new guidance file using the PDS Guidance Editor. For a detailed explanation of the Guidance Editor, see the Guidance Editor instruction movie. Or enable Edit mode in the Plan view and right-click in the view. From the Context menu, you can add different guidance files directly. Alternatively, waypoints can be added or selected directly using the Acquisition toolbar buttons. Numeric views are also frequently used, and can display any numerical value derived from data, data sources, or computations. All that values can be derived from the raw data standard view. Simply drag and drop any value from the raw data view into the numeric view to display it. Right-click in the view to open the context menu, then select Edit Page to manage the data items shown in the view. Select Properties from the menu to change the look and feel of the view by adjusting text colors, background color, and other settings. Set up alarms to be notified when certain conditions do not meet your quality criteria. For example, when the minimum number of satellites used by the position system is not met. In this example, right-click the number of SVs data item that was dragged from the raw data view and select Define Alarm. In the dialog that opens, you can define the alarm conditions and specify how you want to be notified when the alarm occurs. In this example, we set an alarm that is triggered when the number of satellites used drops below 8. We choose to be notified by blinking numerics. The display of numeric values is not limited to the numeric view. Numeric layers can also be added to the plan view to display values directly in the view. Configure the data item format. Select the source item to be displayed. Define the annotation position in the view and adjust font size and coloring as required. The numeric data item is visualized in the view. As navigation is also used to guide the helmsman, the helmsman view is added in this example. In this example, we require the helmsman to follow the route. From the view properties, we select therefore route as the computation selection. The off-track distance is shown using colors. At the bottom of the view, key navigation information is displayed, including the vessel heading, line heading, current line, the heading to steer to the next point, and the distance to that point. Discover the full range of features PDS offers for efficient, safe, and multifunctional navigation.